So on page 11 of your notes, we are going to look at resistance and non-resistance. And the first thing that I need for you to do is put each of these lists into your calculator and then fill in the table for all the information. So pause the video and get all of that done. Okay, so pause the video long enough, double check, make sure all of your answers match mine. Then once you've double checked and made sure that all of your answers match, I want you to find out and verify whether or not there are any outliers for either set. So do that next. You can do all of your work right below where it says list 1, list 2, because that's where I'm going to show mine. Pause the video, don't cheat and peek. I'm back. Sorry for the transition. Anyway, so in order to figure out if I had any outliers, so again, make sure everything in your list matches. This is, in fact, the sample standard deviation, so you should be reading the S sub x. But in order to calculate if I had any outliers, of course, I need to use my magic formula, which is the 1.5 times the IQR. I forgot to write it in that first one. And then I take that and subtract it from Q1 to get the low end for the low outliers, and I add it to Q3 to get the high end for the high outliers. And so since my data sets both had the same inner quartile range and that it was 5, so I was able to use the same Q1 to do the calculation, it didn't matter, and the same Q3 to do the calculation, it didn't matter. So over here, that's why it didn't matter which one I was using, since for the data set, those values were the same. So I can check, is there anything below 27.5 in either set? And the answer to that question, of course, is yes in list 2. And is there anything higher than 47.5 in either set? And the answer to that question is yes, 79. So both 2 and 79 are outliers. And hopefully you were able to get that all by yourself. Hey look, it's my statistics kitty. His name is Patches. He loves doing statistics. Say hello, Patches. Okay, so what hopefully, yes, I know he wants to rub on me. What hopefully you saw from up above is that when I had the set with the outliers, notice it didn't make any difference whether I had those outliers about my quartile 1 or quartile 3 or the median. All of those values in the box itself were exactly the same, but what you do notice different is that the minimum, of course, is different when I have that outlier, specifically the 2 side, and the max, specifically 79, and the mean. So I didn't have you calculate the mean, but I would encourage you to go back and add that below standard deviation so that you can see what happens when I have those outliers. For sure you need to do that. And also the range, when I have the outliers, notice how different the range was on the second set of data. And then also the standard deviation, notice how much way bigger that standard deviation was when I had those outliers. So resistant means they don't change when there's outliers. And again, I would be looking at those if the data set changed on the ends, which your data set did. Notice the other values were exactly the same. So when I changed the low end and the high end to outlier values, that my Q1, Q3, and median didn't change at all. But when I changed those values and turned them into outliers, that all of these values, they just couldn't resist changing. And so they're changed by the presence of outliers. And that's the way you can think about it. They're not resistant to change. They can't resist changing when I put outliers in. And so a perfect multiple choice question that I might ask is, which of the following is resistant? And so you should be able to answer that. I might also ask the question, which of the following is non-resistant? But of course the list would change. And you should be able to generate that question on your own and then make the list. Which of the following is non-resistant? So I would encourage you, make the multiple choice question and then answer it.